Algebra 2 students. This is a video where I'm just going to walk through the 3 graphing problems that you guys are assigned homework. So feel free to watch part of this, all of this, whatever you need. The first graphing problem is x plus 1 over x minus 4. And the first thing I actually am going to do is fill in the bottom table. I think that's the easiest place to start. So remember, some of the pieces are going to be familiar and some are going to be a little new. I'm going to start with the y-intercept. Remember, the y-intercept is the point where you've got 0, comma, a number. So all I've got to do there is plug in 0 as my x. Simplifying, I get 1 over negative 4, which is like negative a fourth, negative 0.25, however you want to do it. Notice that's one of our table values, so I'm just going to put negative 0.25 here. And on my graph, I'm going to plot it, but it's going to be a little bit of a, eyeballing. It's not going to be precise because I've got it labeled in multiple places. So that's probably the easiest place to start. The second easiest place to start might be my x-intercept. Remember, your x-intercept is where you plug in a number and your output is 0, right? That makes it along the x-axis. So I'm thinking about, if my output has to be 0, how am I going to get x plus 1 over x minus 4? How am I going to get that to give me a 0? When is a fraction equal to 0? Think about, is 0 over 5 or is 5 over 0? Which one is equal to 0 and which one is undefined? Okay, so if I want my fraction to be 0, I have to make x plus 1 equals 0, which means that x would be a negative 1. So my point is negative 1, comma 0. So I also could put in the table that when I plug in negative 1, my output is 0. I'm also realizing I forgot to write my y-intercept as a coordinate. I'm just going to real quick put that as well. And this part is a little bit trickier, thinking about which part of the fraction has to be 0. So always come back to a concrete example like this if that helps. Okay, so we've got 2 of our features. The next part is our vertical asymptote. Remember, the vertical asymptote is really thinking about what x is not allowed to be, right? What can't x equal? So I'll put that maybe in words. X can't equal blank. Now let's look at our fraction. I've got x plus 1 over x minus 4. The x value that I can't plug in is a 4. If I plug in a 4, that's going to really mess things up. So think about, the question is, what would make, right, a number over 0, which is undefined? We're not allowed to do that. So when is x minus 4 equal to 0? When x is equal to 4. I'm going to color code that as purple, and I'm going to go in at x is 4, and I'm going to put a dotted line. Remember, that's not actually technically part of the graph, it's just going to be a boundary line to tell me that I'm not allowed to have any points along it. So this is going to serve as my boundary line. Okay. Now, you want to think about the vertical asymptote as a boundary. Comparatively, the horizontal asymptote is going to be a trend line. It's going to be what happens as you plug in really, really big numbers and really, really small numbers. Okay. If I do that, I've actually got this plugged into Desmos. So I'm going to go here. So I've got my function written in Desmos, and you can see this is one of the rational functions with the 2 parts or 2 branches. I'm going to plug in like 100 and see what I get. And keep making it bigger. It's getting really close to 1. What happens if I try negative numbers? It's getting really close to 1. Notice if you look at the far right side and the far left side of this graph, if I kind of zoom in, this is the line, I'll graph the line y equals 1 just so we can have that placeholder. Notice as I move, it's getting closer and closer, and it's kind of hugging that line. So we want to think about the horizontal asymptote as a trend line. It's kind of following that trend and getting close to 1 on our ends, right? It's the end behavior or the trend. So I'm going to go here. And I'm going to make my asymptote maybe orange, right? When I plugged in like big numbers, small numbers, it was both approaching y equals 1. So your horizontal asymptote, remember, is just looking at the end behavior or the trend of the end, right? So I'm going to put a dotted line at y is equal, a little off right there. I'm going to put it at y equals 1. And then as far as doing the branches, really you just need at least 1 point for each branch to kind of get the shape, right? But what I've done here is I've asked you to do a table of values. So to plug in 1, to plug in 2, 3, 4, and 5. My general rule of thumb is if you think about this graph, right, it's going to have the 2 sections, the one section and the other section. And the 2 sections are separated by that purple line, right? My general rule of thumb is you need to have at least 1 per section, 1 point per the sections. Because generally we'll have just a little curve and you can kind of approximate it curving along the asymptotes. So I'm going to use my Desmos, actually. I'm going to use that to generate my other points. So I'm just going to split my screen in half, right? And if I use Desmos, I can just make it a little bit more efficient. I've got my function here. So I can type out g of 1, g of 2, calling back to function g, and find corresponding outputs for my input. So g of 1, negative 0.6 repeating, g of 2, negative 1.5, g of 3 is negative 4, and g of 4 is undefined. Remember, that's because of our asymptote, right? X can't actually be 4. And then g of 5 is equal to 6. So I'm going to go back here. Remember I said generally the rule of thumb is you only really need 1 point for each of the sections or the branches. That's normally what I hold my students to when we graph by hand. But since we have the table, it makes sense just to graph all of our points, right? So it looks like negative 0.6, negative 1.5. I'm just going to get these points. 3 is negative 4. And then I'm just going to connect them, right? Go up along the asymptote, approaching it, kind of hugging it. And then I also have the point 5, 6, right? Which is great because I need to have at least 1 point on each side, and then I'm going to kind of curve up. And generally we have that pattern of curving down along the asymptote. So that's how I do a typical graph. Okay, we'll look at another one just for practice. So for this one, let's do the same thing. Let's focus on getting our intercepts first and getting our asymptotes. So the first thing I'm going to look at is the y-intercept. That's always kind of the easiest place to start in my opinion. So I'm just going to plug a 0 into my function. Looks like I'm going to have negative 2/3. So the point 0 has an output of negative 2/3 in my table. And I'm just going to kind of plot that right here. Okay, for my x-intercept, remember this is the one that's a little trickier for us to get like our brains wrapped around. If you want your fraction, that x minus 2 over x plus 3 to become a 0, right? Remember the top of the fraction has to be 0. The bottom being 0 would make it undefined. So when is x minus 2 equal to 0? If x is equal to 2, right? It's kind of the opposite of what you're expecting. So when I plug in 2, my output is 0. I'm going to add that to my table, and I'm going to plot my point. Okay, and I'm just going to highlight, I got that information from kind of right up there. That's where I'm pulling that information from. And then we want to think about our asymptotes. So remember my vertical asymptote, I'm always looking at the denominator of my fraction. So I'm going to color code that. I'm thinking about what would make the bottom 0 or the denominator 0. What would make the denominator 0, right? So when is x, let's see, x plus 3. When does x plus 3 become a 0? Because then I have a number over 0. I've got 0 in the bottom of my fraction. That's undefined. So if x was equal to negative 3, so that's going to be my vertical asymptote. Remember, a straight up and down line has x equals, because this line, every x-coordinate along the line is equal to negative 3. The y-coordinates or the heights will vary, but your x anywhere on that purple dotted line is always negative 3. The tricky thing is your horizontal asymptote. So I'm going to go over to Desmos real quick again. Okay, so I've got my function switched over to the correct one, and I'm going to plug in like 100, keep going bigger. It looks like it's getting kind of close to 1. Remember, the horizontal asymptote is looking at what's happening on the ends. It's your end behavior of your function. If you look at the graph visually, if I was to add in y is equal to 1, right? I'll make it a little dotted line so we can kind of visualize it, right? Notice it's kind of hugging that asymptote and going and approaching it. If I look at the ends, right, I'm focusing only on what's happening on the far left and the far right. I'm not concerning myself in the middle area, because notice in the middle area here of my graph, it's doing things other than going towards the asymptote. So I'm really focusing on my end behavior. So my horizontal asymptote is going to be y is equal to 1. And remember, that's looking at end behavior. So make a little reminder, it's your end behavior. And you're looking at how the graph is trending. I'm going to go ahead and put that, oops, there we go. I'm going to go ahead and put that for y is equal to 1. Okay? And now the last thing is to get some points. So what I've done is the same thing as before. Oops, and I guess I never changed my table to make it a G. I'm going to use the values over here to get the corresponding points. Remember these are all calling to function G. I noticed I didn't do -1. -1 is -1.5. -2 is -4. I'm going to switch them to give me -3 and -4. Oops, there we go. So -3, remember that's undefined. That's because of our vertical asymptote. We can't actually equal that point. And now with these points, I'm going to plot them. Remember, the general rule of thumb is you need about 1 point for each piece, right? On the left side of my purple vertical asymptote, there's going to be one section of the graph, and on the right side, there's going to be another. So I'm just going to plot all these. More points than I generally will hold students to, but you know, that'll give you a better understanding of what the shape is like. So let's get -2 is going to be equal to, let's see, I think that's supposed to be -4. I think it's supposed to be -4. I kind of wrote it a little funny. But that would kind of make sense here, right? We've got that good trend line going there. And then I've got 1 is like -0.25, 2 is 0, 3 is just a teeny bit bigger. Notice I would probably just have used the green and the blue points and just called it a day at that, but you can always do more. And then you do need 1 point over here to kind of see that general trend. Make sure it's on the top section rather than on the bottom section over here. That's really the only question at hand. Okay, guys, we're going to go to our final graph. Our final graph is a little bit more complicated. I'm going to first find the y-intercept using the same steps, plugging in 0. So it's a super beautiful value. It comes out to about 2/9. Then I'm going to find my x-intercept. Remember, you want to think about what will make the top of my fraction 0. That will make the output 0, right? Because if you have 0 over something, that means it's 0. So we're just looking at the numerator. X equals 2 would make that happen. So my x-intercept is going to be 2, 0. Whereas my y-intercept, I'll write that out real nicely there, is 0, 2/9. So I'm going to get that point plotted as well. And then at this point, I didn't actually give you guys a table, so it's going to be a little bit more on us to think of what points to plug in, right? But we can still do our asymptotes. Notice for my vertical asymptote, what's going to make that denominator equal to 0? There are, oops, wrong one, vertical as I was saying. There are actually 2. X equals 3 and x equals -3 would both make a 0 in the denominator, which we know we can't have in a fraction. So we're not allowed to equal these values. So I'm going to put boundary lines because we're not actually able to have anything on that line. It's creating a space where we know that we can't have an x value of 3 or an x value of -3. Okay, so I'm going to put those in. And then from there, we need to get our horizontal, right? Our horizontal asymptotes. I'm going to open up my screen. I've got my function plotted here. I'm plugging in a really big negative number, really big positive number. It looks like my asymptote is going to be y is equal to 0. Okay, so that's my horizontal asymptote. So I've got that drawn in. I can see that there is 1, 2, 3 kind of areas based on my vertical asymptotes. So I need to have something in each of those 3 sections. I'm going to suggest 1 point over here, a point kind of to see what happens on this piece in the middle, and then 1 point on the far right section. And then there's 5.